Hello, welcome to Off Grid Thoughts channel. Well, this video is about DC charging, or essentially off-grid charging, uh, an 18-volt Mansfield cordless drill. So, I did a previous video on this drill, and it's pretty much, completed everything I was going to do to it, such as install a half-inch capacity chuck. And I had picked this drill up at a thrift store, paid about $2.50 for it. I put a battery adapter on it, just due to the fact that it originally come with 18 volt nickel cadmium battery. Those batteries are not very available these days. I'm not saying that someone couldn't find one somewhere, but so I had converted it to lithium ion. And I picked up, one of those slow chargers for it, AC outlet chargers that, pretty slow charging rate, about 1.8 to 2 amps. And, since this is an off-grid channel, I wanted to be able to find ways to off-grid charge or DC charge this type of battery. It's 18 volt lithium ion battery. So in the last video about this drill, I pretty much said that I would try to do that and make a video about what my results were when I tried what I was going to try, and that is try charging with a hobby charger. And in this case, this is an AC DC charger, so you can either use a 12 volt automotive battery, or you could use a 12 volt, or essentially like a 12.8 volt LiPo 4 battery, like a solar off-grid battery, with this unit to charge small batteries. Or like in this case, this particular charger, you can plug it into a wall outlet. So that was the entire goal, is to be able to have an off-grid way to charge up even an 18 volt tool battery, such as in this case. And what I've done is I picked up this little dock station. That's what it essentially is a dock station. There was kind of a little bit of a thing a few years ago where people were using their tool batteries to start like smaller 4-cylinder cars, and in some cases, the small 4-cylinder engine trucks, with one of these, using a tool battery, because it was like 18, or depending on the brand, 18, 20 volts, 21 volts, and they would connect it to their dead 12 volt automotive battery. So this was kind of like the dock station, or it's like a mini jump starter, but all it is a dock station. And the wire that comes out the back, really high quality wire. It's like high heat resistant, thermal wire, like charging cable, like battery chargers usually have, with smaller charging units like this. well, not so much battery chargers, but like what smaller high energy battery packs would have, like this kind of wire. It's pretty robust, and it came with some high quality battery clamps, but I removed those for a different project. But what this is an extension cable, 12 gauge, a Dean's T-plug female extension cable that I cut one end off of and then connected it to this high quality wire. So I essentially have a very high quality extension charging cable connected to a high quality wire on this little dock station. So that allowed me to do was just plug it directly in. And so this battery, I can remove this battery and just put it on this little dock station. And only on the Makita, on the older Makita setups, there's two blades, negative and positive, and like this one, the batteries, they usually have a third connection to, that's like to tell either, like a Makita type charger to just shut the whole charging process off because there was some kind of overheating, or and on the newer tools, the Makita tools, that would also tell the tool just to shut off if there was some kind of heat issue. Because these batteries have an internal BMS, battery management system, so that's pretty much self-contained. But in this case, doing this homemade, I didn't have any concerns, not really, about using a charger like the iMax, because this is pretty much like a peak charger. So, if you read the instruction manual to a charger like this, and you set it properly, you really shouldn't have any issues. It's going to shut off if something is not connected right. It's going to shut off if it doesn't match the algorithm that it's charging at. If it detects something outside of its algorithm, it's just going to shut off. So, it's not really going to do anything outside of its charging algorithm, and the BMS is only going to accept whatever charge in its parameters as well. So you've got safety with the BMS. You've got safety being a peak charger, only going to do within it in its algorithm. That'll shut off, or this will shut off. So the only other concern is the fact if you have your wires are robust enough, something like that. This being kind of like a jump starter, you could say, well, it's pretty robust. There's always a risk with anything, but I felt like the risk was pretty low. And so I've tested it. And I'm just kind of here in this video to just kind of talk about the results of that. Well, it worked. And you pretty much, you just need to either watch videos on YouTube or read the manual. and to be able to set it to lithium ion, has to be set to lithium ion. Since you're not having because the BMS is self-contained, you don't have a balance plug. It's balancing this through the BMS. So you would want to set this to just charge, not balance charge, just to charge. There's a setting for that. So charge. And since this battery, even though there's 10 cells in here, there's 2 strings of 5. So this is actually wired as a 5-cell pack, even though there's 10. So there's 2 strings of 5 wired in parallel. So it's set up to charge like a 5-cell, or what you call 5S. So you would basically read the instructions on this. Make sure you're set to like 3.6 volts on the cell setting, 5S, and this will charge. You can set the amps, because this charger goes from like 2 to 20 volts, 1 to 6 amps. So I set this to fast charge. I set it to 6 amps. This will automatically detect the present voltage, and it was charging at over 20 volts on the charge side of it. And it starts off charging high amps, but then as the battery is reaching full, it tapers down to like like 0.6 or 0.6 amps, like just over a half amp. And that matches, and it bounces back and forth. It'll go to 0.3 to 0.6, depending on where the charge rate is at. But it'll start out at higher amps. But in this case, this battery was already charged up. I had just been testing the drill, so I had spun it quite a bit. I used it on one small project. So this battery, when I tested it, was essentially almost full. Maybe had like probably less than 10% capacity was used with the little project I used the drill on. So it really, there wasn't hardly any amount of power taken off of this, off of the full battery. So it was doing what it would naturally do. That's the information I can report. So as far as a dead battery, how long would it take for this to charge a battery that you would have to charge it up again? I don't know how long it would take, but what I do know is I had it on the fast charge setting, 6 amps. So basically the maximum you could set this to, and it was just in the mode of it was in the peak mode, because it's a peak charger, of giving it very little at the end of the battery being almost full. So it was behaving normally. So takes a little bit to figure out how to change it to lithium ion mode. And again, you can refer to videos about this charger, but it behaved normally. And there wasn't anything like the BMS shutting the pack off or anything like that. Nothing like that happened. So, because this is more of a basic design, I can't speak for other brands. This is a Makita type. So that's what I have to report on this. So I basically, I consider the project of making one of these a success. It worked. I'm not sure exactly, about other brands or other types. I don't know, but it appears to have been a success. But I have not tested it with a dead battery yet, or a battery that needs to be most of its capacity charged back up. I haven't tested that side of it. So, and this did not shut off. I didn't leave it on there it was just still getting to the end of the charge. So, but it never shut off. I ran this long enough to where I would know, okay, if there's a problem, it's going to shut off, and it didn't shut off. It was still doing its thing. So there's no issue. All right, until the next video, thanks a lot for watching. Don't give up on your off-grid dreams. God bless.